So we're going to start on calculating distance today. We're going to start with kind of a basic idea here of finding distance between points that share a common coordinate, which is just another way of saying that they're either horizontal, right and left of each other, or vertical, up and down from each other. So to find the distance of points on a graph that are directly across from each other, which I just told you was horizontal, right? That right and left is horizontal, or directly above and below each other, which is vertical, we can simply count the spaces between them. We don't really need a formula for this. We can just count and go, well, there's 1, 2, 3, sorry, this is a little slow, 4, 5, and 6. So we have 6 spaces, so it's 6 units. It's a distance of 6. And if they were vertical, I would do the same thing. I would just count the spaces between. If you notice, I didn't start 1 here. I did a jump. The jump was 1. So it's 1, 2, 3. So be careful when you're counting. The first one you're starting on is basically 0. So if that helps, you can go 0, 1, 2, 3. Okay. All right. So the next one, we're very rarely going to have points that are nicely, right across from each other or above and below each other. We're more than likely going to have points that are diagonal from each other. Okay. So to calculate the distance between the point L here, which they give you the coordinate, and point C, so they don't give you the coordinates on the graph, but they do give you the coordinates up here. We need to use what's called the distance formula, okay? Because we can't simply just count between them now. And they're asking us to give an exact answer, not a decimal approximation. So if we get to the end and we can't actually take the square root of a number, then we leave the square root sign, okay? And we'll deal with that when we get down to the bottom here. So we can use the formula for distance, D, between points L and C. So if you notice, I put these in here and I'm labeling them. So this is x1, y1, and this is x2, y2. That simply means this is point 1, and this is my x coordinate for point 1 and my y coordinate for point 1. This is my point 2. Here's my x coordinate for point 2 and my y coordinate for point 2. Remember, all coordinates go x, y. They're an ordered pair. They always go in order x, then y, and that refers to the x and the y axis, right? So if I have more than one point, I need to label them. So I'm not just saying, grab the x, grab the y. Which x? Which y? Oh, the x from point 1, the x from point 2. So just that labeling system helps us know which x we're talking about or which y we're talking about. So here's the distance formula. We have d equals the square root of the difference of the x's. So I'm going to subtract the x coordinate from point 2 from the x coordinate point 1. And then I'm going to square that, plus the difference of the y's squared. So the y coordinate from point 2 minus the y coordinate from point 1, and then whatever I get there, I square that. Once I've squared them both, then I can add them together. And if I have a number that I can take the square root of, then I'll do that. If I don't, then I leave it because it says no decimal approximation. Okay, so let's go ahead and start filling this in. So x2, well, that's -1. And then we have x1, and remember the minus is already there. So if this is also a negative, if you notice I have a double negative here. So it's minus -6. Something's going to happen there. Whenever I hear a double negative, minus negative, it's going to end up being a positive. So we'll deal with that in a moment. Plus, now we're going to do y2. So y2 is 4. And then we're going to do y1, which is 8. So now I've filled in my pieces. I just need to go through and simplify. So I have -1 minus -6. So remember I told you that's going to turn into a positive. I know it didn't quite line up perfect there, but the minus negative turns into a plus. So I have -1 plus 6. They're opposites, so I'm going to subtract, and the bigger number, which is 6, is a positive, so my answer will be positive because I have more positives than negatives, okay? 4 minus 8, that gives me a -4. All right, so now I'm going to square each one. So now I'm going to go 5 squared, and that gets me 25, and -4 squared gets me 16. Remember, this is not 5 times 2 or -4 times 2. It's squared, which means it tells me how many times to multiply this number by itself. So 5 times 5, 5 2 times. Not 5 times 2, 5 2 times. It sounds very similar, but it's very different. Same thing here. It's -4 times -4, which gives me a positive 16. All right, so now I can add these two together. Since we've dealt with the parentheses, we've dealt with the exponent, I can go ahead and add. So 25 plus 16, I get 41. And if you know your squares, hopefully you know right away, 41 is not a square. It's in between 36 and 49, which are squares, but 41 is not a square. So we would just leave it the square root of 41, because if I took the square root of 41, I'm going to get a really funky decimal there. And it told me not a decimal approximation. So that's how we find distance on a line using the distance formula, and if they're sharing a coordinate. Hope that helped, and I will see you in the next video.